Welcome to Ask and Learn.
In this question, we have been asked to balance the redox chemical reaction. So we will start with part A, which says that we have to balance the redox chemical reaction in acidic solution. So first we will divide the reaction in two halves. We will start with the chromate ion. So Cr272 negative goes to Cr3 positive. So in this case, we will balance the chromium atoms first. So on the left hand side we have two chromium atoms, and on the right hand side we just have one chromium atom. So to balance that we will add a 2 here. Okay, and now we will balance the oxygen atoms. So to balance the oxygen atoms, we will count the number of oxygen atoms at the left hand side and then balance it on the right hand side. So on the left hand side we have 7 oxygen atoms, and to balance that we will add 7 water molecules here. So that's what we do whenever we have to balance the oxygen atoms. We always use water molecules. And then if we have to balance the hydrogen atoms, we add H positive ions in the acidic solution. So on the right hand side we have 14 hydrogen ions, and to balance that we will add 14 H plus on the left hand side. And now we balance the charge. The overall charge on the left hand side is 12 positive, and on the right hand side is 6 positive. So to balance the electrons we will add 6 electrons here. Now since the electrons are gained overall, so this reaction is a reduction reaction. Okay, and now the second half of the reaction says that zinc goes to zinc 2 positive. Okay, and to balance that we will add 2 electrons here, because there is no oxygen, there is no hydrogen, the zinc atoms are already balanced, so we just have to balance the charge. And this comes out to be an oxidation reaction because electrons are lost during the course of reaction. Now since we have to balance the overall charge, we will multiply the second equation by 3 to balance the um, number of electrons. So this gets cancelled because the number of electrons are same, and the overall reaction comes out to be 14H positive, Cr2O72 negative, 3 zinc atoms goes to 3 zinc 2 positive, 2 Cr3 positive, and then 7 water molecules. Okay, and now we have to decide like which is the oxidizing agent and which is the reducing agent. So the number of, or the oxidation state of chromium in Cr2O72 negative is +6, and that goes to +3. Okay, and the oxidation state of zinc is 0, which goes to +2. Therefore Cr2O72 negative is our oxidizing agent, since it is oxidizing zinc to itself get reduced, whereas zinc will be our reducing agent because it's reducing Cr2O72 negative and itself getting oxidized. Okay, so that's our part A. Now for the part B, we have an example of a basic solution. So part B says that it's a reaction of having hydroxide ions with iron. So what we do is, once again we take the half of the reaction. So MnO4 negative goes to manganese dioxide. Okay, now first we balance the oxygen atoms, since manganese atoms are already balanced. So to balance the oxygen atoms we will add water molecules on the right hand side, 2 water molecules. So now if you see 2 plus 2 here, that is 4, and 4 oxygen atoms on the left hand side, so oxygen is balanced. Now we balance the hydrogen atoms. To do that we will add 4 H positive on the left hand side. Okay, and now we have to balance the charge. So overall charge on the left hand side is 3 positive, whereas overall charge on the right hand side is 0. So to balance the charge we will add 3 electrons on the left hand side, sorry. Okay, and now we have to balance the second half of the equation, which is FeOH2 goes to FeOH3. Okay, and now to do that we will count the number of oxygen atoms on the left hand side and the right hand side. So on the left hand side we have 2, right hand side we have 3, so we will add one water molecule on the left hand side. And now we balance the hydrogen atoms. So on the left hand side we have 4 hydrogen atoms, on the right hand side we have 3 hydrogen atoms, so we will add one H positive here. And now we balance the charge. So on the left hand side we have 0 charge, on the left hand side we have 1 charge or 1 positive charge, so we just add a electron here. Now the first reaction is the reduction reaction, and the second reaction is oxidation reaction. Now if we have to balance the number of electrons, we will multiply the equation by 3 to balance the number of electrons. So this gets cancelled, okay, and the overall equation comes out to be and so we have 4H positive on the left hand side and 3H positive on the right hand side. So 4 minus 3 is 1, so we'll have 1 H positive ion on the left hand side. And then we have 3 water molecules on the left hand side and 2 water molecules on the right hand side, so we will be left with 1 water molecule on the left hand side, and this will go to MnO2 plus 3FeOH3 plus OH negative. Oh no, yeah, that's it. So now we have to balance the H positive. Basically we are in the basic solution, so we have to balance the equation using OH negative ion. So to balance the H positive, we will add one OH negative here and we will add one OH negative here. Now this now so this thing overall will become water molecule, and that will combine with this water molecule, so the overall equation come out to be so this is our overall equation. Now if you see, the oxidation state for the iron is actually increasing, so this one is our reducing agent and the manganese will be oxidizing agent, since it's oxidizing iron by itself getting reduced. So this is our part B. Now we move to part C. So the part C, again we will divide the overall reaction into two halves. So the first half will be zinc goes to zinc 2 positive. So in the part A we saw like how we balanced it. So we will just balance the number of electrons here, and this will be our oxidation reaction since the number of electrons are lost. And now the second half of reaction is, so first we will balance the number of nitrogen atoms by adding 2 here, okay, and now we have 6 oxygen atoms on the left hand side, so we will balance it by adding 6 water molecules on the yeah, so 6 water molecules on the right hand side, okay. And now to balance the number of hydrogen atom, we will add 12 H positive on the left hand side. And now to balance the charge, there is 10 positive charge on the left hand side and 0 positive charge on the right hand side. So to balance it, we will add 10 electrons on the left hand side, okay. And now this is our reduction reaction, and to balance the electron, we will multiply the oxidation reaction by 5. So this overall electrons count get cancelled and we are left with what, 2 2NO3 negative plus 12H positive plus 5 zinc atoms um, going to N2 plus 5 zinc 2 positive plus 6 water molecules. And now if you see, the zinc is getting oxidized, like the oxidation state goes from 0 to +2, so that is our reducing agent. And the NO3 negative, the oxidation state for nitrogen is decreasing, which means that it is oxidizing zinc to itself getting reduced, so this is our oxidizing agent. And yeah, this is our complete balanced equation, and we have our oxidizing agent and reducing agents. And yeah, hope this helps.